Hello future pilots, let's start the next chapter of instrumentation, which is the turn and slip indicator. So in this video we are going to study both the turn and slip indicator and also the turn coordinator. So let's get started. The turn and slip indicator is a cockpit instrument essential for pilots' orientation during flight maneuvers. So the turn and slip indicator is a cockpit instrument. So if you look at the 6 packs of aviation, you will look that there's a turn coordinator or the turn and slip indicator. And how is it essential for the pilots? Because this instrument shows both that at which rate the aircraft is turning and also at which direction the aircraft is turning. With that, there's another component to it, which is the slip indicator, which shows us that the turn that the aircraft is making is balanced or not. So basically, the turn and slip indicator consists of two components. The first one is the turn indicator and the another one is the slip indicator. So let's now talk about the turn indicator. It estimates the rate of turn about the aircraft's vertical axis. So the function of the turn indicator is to show us the rate at which the aircraft is turning and also the direction at which the aircraft is turning. So let me explain. So if the needle is towards the left, that means the aircraft is turning towards the left, and if the needle is pointing towards this scale, as you can see, this means that this aircraft is turning at a rate of 3 degrees per second, or we can say 360 degrees in 2 minutes. And what this turn is called is that rate 1 turn. Alright, and same if the needle is pointing towards the right and it is pointing towards this scale, that means that the aircraft is turning right and it is maintaining a rate 1 turn, which is 360 degrees in 2 minutes, alright, or 3 degrees in 1 second. Alright, now we will talk about the slip indicator. The slip indicator is, what is the function of the slip indicator? I have already said that its function is to show that the aircraft turn is balanced or not. Alright, so we will read about this later, the full construction. And here it is written that although both are often housed together, each functions uniquely and can be understood independently. So what is this? Two are not associated with each other. Alright, though it is together, as you can see, it is inside the same instrument, but it works uniquely and independently. So now we are going to look at the construction of turn and slip indicator. So this is the most important part of the chapter. So before we start, you should know that the turn and slip indicator contains a rate gyro. That means it has only 1 degree of freedom. So what happens when an aircraft turns? So whenever an aircraft turns, what happens is that a force tries to twist the gyro. So in this case, if you see, you have to assume that the aircraft is turning towards the left. Alright. So as the aircraft is turning towards the left, right, as the aircraft turns, a force tries to twist the gyro, and this will cause a force to be applied in this direction, right? So this force we call is the primary torque. So if you know by the definition of precision that the force is not applied where it is acted, it is applied 90 degrees in the direction of rotation. So it will be applied here. Here it is called, it is the primary precision, right? So it will be applied 90 degrees in the direction of rotation, right? So what will this cause? So as the force is applied here, this will cause the gyro to tilt, right? So as the gyro will tilt, you can see the gyro is also connected with the needle. So as the gyro is tilted towards the right, the needle will go towards the left, as you can see, which will make us which will indicates the rate at which the aircraft is turning, and also the direction at which the aircraft is turning, right? So this is how it indicates. But what is the function of this calibrated spring? So this is very important because the spring keeps the gyro's movement limited. It doesn't let it tilt too much, right? And also it retains the pointer to the center after the turn. So whenever the turn finishes and the aircraft is now again straight and level, what happens is that the rotor, the spring again makes this rotor to come back to its original position, the gyro in its original position, and thus the needle again centers itself. So now we are going to look at the power sources and calibration of the turn and slip indicator. So let us read. The gyro can be powered by electrical current or airflow. If electrically driven, a warning flag alerts pilots to power loss. So the turn and slip indicator can be powered by both electrically or by airflow, right? So if it is electrically driven, there's another warning flag. So here is the warning flag. So it flashes whenever there's a power loss. So it indicates the pilot that the instrument is not working anymore if it is electrically driven, right? Unlike rigid gyros used for directional indicators, the instrument operates at a lower speed for better sensitivity since it measures precision rather than purely maintaining orientation. So what this statement is saying, that before in the previous videos also we have seen that the DGIs or the artificial horizon, everything requires a high rotor speed, because high rotor speed increases the rigidity, right? So as it increase, but in this case we want precision to happen, right? Because by precision only, by the tilting of the gyro only, it indicates the rate at which the aircraft is turning and also the direction, right? So what we do is that keep the rotor speed low, which will make the precision more, and which will cause which is helpful for us in this case. Slow gyro rotation due to failure reduces accuracy, causing the indicator to display a slower rate of turn than is actually occurring. So let me explain you. So if the gyro is spinning too slowly, what it means is that the rigidity will be low. So this makes the spring not stretch enough, because the rigidity is pretty low, right? Because the speed of the gyro is low, the spin rate of the gyro is low, which makes the rigidity low, which will cause the spring to not stretch enough. So if the spring is not stretched enough, that means that the pointer will show a slow turn rate, right? So even if the aircraft is turning at a very fast rate, the needle will still show us a slow rate. So this will what will happen is that we will complete the turn way sooner than expected. So in the case of fast rotation, what will happen? It will make the spring more stretched. So what will make it will indicate a faster rate of turn than it is actually occurring. So what will happen is that the aircraft is actually turning very slow, but the indication is showing that the aircraft is turning at a faster rate. Now we are going to study about the slip indicator or the inclinometer. So this is a capsule which is filled with a liquid, and there's a ball in the middle. But that doesn't mean the ball will be always in the middle. It will be in the middle only when the turn is balanced. So let me explain. So if the ball is centered in a turn, so for example, the aircraft is turning towards the left or the right, and the ball is towards the center, that means that the aircraft is maintaining a balanced turn or a coordinated turn. All right. But if the ball is on the turn side, that means if the needle is also towards the left and the ball is also towards the left, this slip indicator is indicating us that the aircraft is slipping. All right, I will explain you slipping and skidding. All right. And if the ball is in the opposite direction of turning, for example, the aircraft is turning towards the left, but the ball is towards the right. So in this case, you can see. So what this is indicating is that the aircraft is now skidding. I will explain you what is skidding. So what is the what we have to do is that we have to step on the ball. All right. So what does this mean is that for example, if the aircraft is turning towards the left and we see that the ball is towards the left, so what we have to do is that we have to step on the ball. That means we have to put left rudder wherever the ball is. We have to put that rudder to centralize the ball again and to have a balanced turn or a coordinated turn. And for example, that aircraft is turning towards the right and the ball is towards the left. All right. So again, we have to put left rudder to centralize the ball again. Okay. So this rule is called the step on the ball. Now I will explain you the physics behind this slip indicator or the inclinometer. So let us look at this, and I can explain you via this image. All right. So when in a balanced turn, what happens is that the centripetal force and the centrifugal force is equal. All right. But what happens in the case of slipping? What happens is that the centripetal force is now more than the centrifugal force, which causes the ball to move to the turn side. So as you can see here, you can see that as the aircraft is turning towards the left and the ball is also towards the left, that means that this centripetal force is more than the centrifugal force, and this is the reason it causes the ball to go towards the left. All right. Now what in the case of skidding, what happens is that you can see the skid, right? So in the case of skidding, what happens is that the centrifugal force is now more than the centripetal force. I am going to write this: centrifugal force is more than the centripetal force. So this causes the ball to move to opposite the turn side. All right, I hope you understand the physics behind this. Next, we are going to study about the turn coordinator. So it is very similar to turn indicator, but there's some differences made. All right. So what are the differences? As you can see, there was needle, but now it is been replaced by a miniature aircraft. So let us read. The turn coordinator is a modern evolution of the turn and slip indicator. So as I've already told you, its gyro axis is tilted about 30 degrees from the fore aft axis of the aircraft, allowing it to register both yaw and roll, which improves the immediate response to turning. So what happens is that you have seen the gyro, right? So in this turn coordinator, it is tilted about 30 degrees fore aft axis of the aircraft. So why it is tilted? The reason is that it makes the response time to turn very less, means it makes it more sensitive to turns. Next, the movement of the gyro is related to a miniature aircraft wing symbol on the instrument, aligning with the direction and rate of turn. So as you can see, the needle is now replaced with this miniature aircraft. So if now in this case the aircraft is turning towards the right, and the aircraft is the wing of the aircraft is pointing towards the scale, that means that the aircraft is maintaining rate 110. I have already told you about the rate 110. That means that it is maintaining 3 degrees per second or 360 degrees in 2 minutes. Next, the slip indicator is retained, but instead of a needle, the bank direction is shown by the wing symbol. As I have already told you that the needle is now replaced and it is shown by the the wing. So as you can see, the aircraft is turning towards the right. That means the wing is also towards the right. That means that this instrument is also indicating us that the aircraft is turning towards the right. So here's the end of the chapter. This notes you can get from the description itself. Thank you for watching.